All right, so let's check out and see how this indeterminate form rule works out with a couple of examples. So we're going to use L'Hopital's rule and evaluate the limit as x approaches 0 of 2x over x plus 7 square root of x. Well, certainly substitution is going to produce 0 over 0 right here, so this is a definite candidate for the L'Hopital's rule treatment. Okay, so that means we're going to have to go through and start taking a couple of derivatives. So we're going to be taking our limit as x approaches 0 of the derivative of 2x, well that's 2, divided by the derivative of x plus 7 square root of x. If we work that out, that's 1 plus 7 divided by 2 times the square root of x. And I don't know, I don't like carrying too many extra square roots and fractions within fractions. It makes me a little nervous. So what I'm going to do is I'm going to multiply my numerator and denominator by 2 square root of x right here to rewrite this guy. Well, I could just multiply by square root of x, I suppose. It doesn't matter, but I'll stick with 2 square root of x just for fun. Let's see what will happen. Well, this is going to become the limit as x approaches 0 of 4 square root of x, and in my denominator I'm going to get 2 square root of x plus 7. So now substituting in 0 for x produces 4 times 0 in the numerator over 0 plus 7 in the denominator. It's not indeterminate, and we know that this limit is going to be 0. So there we go. Okay, so this rule does actually seem to produce a value. Now, you could verify this by taking this function, graphing it, let x approach 0, or getting a table and just kind of verifying for yourself was a good exercise. But let's talk about another one here. Let's talk about this limit as x approaches 0 of x minus sine of x over x cubed. Again, substituting in 0 produces 0 minus 0 in the numerator over 0 cubed. Well, that's indeterminate, so another candidate for our L'Hopital's rule treatment. So let's try it. What happens now? Well, in this case, this derivative of the numerator as x approaches 0 is going to be 1 minus the cosine of x divided by 3x squared. Uh-oh, I see another problem, right? Because if we take this derivative right here, we see that, well, by letting x go to 0, we're going to get 1 minus the cosine of 0. And cosine of 0 is 1, which means that our numerator is going to go to 1. And we've got 3 times 0 squared now in the denominator. And, well, that's still 0 over 0. So the question is, well, what happens if L'Hopital's rule fails us like this? Well, the rule can be extended and say, well, if this limit does not give us a value other than an indeterminate value, take your derivative again. So let's do that. Let's see what's going to happen now. Let's take the limit as x approaches 0. The derivative of 1 is 0. The derivative of cosine of x is negative sine of x, so it's plus sine of x now. And our denominator becomes 6x. Uh-oh. Yeah, here we go again, right? Sine of 0 is 0. 6 times 0 is 0. So this says, let's extend L'Hopital's rule one more time. What's going to happen if we take our derivative? Well, yep, we're going to get an interesting expression now. A limit as x approaches 0. What do we get here? Cosine of x divided by 6. Wow, hey, we're going to get a value now, right? Because L'Hopital's rule didn't work twice. Doesn't mean we couldn't try it a third time until we get a value, and of course it does. Cosine of 0 is 1. Divided by 6, there's our limit. L'Hopital is a beautiful thing.